All right, so this is chapter 5, section 6, and it's called Radical Expressions and Rational Exponents. So we're going to be dealing a little bit with radicals, a little bit with exponents that are fractions, that kind of stuff. Just a quick warm-up of skills that you need in order to be able to do all this stuff. Okay, here's some examples dealing with exponents and that kind of stuff. So if you look at number 1, if I have two numbers raised to a power and the base is the same, and I'm multiplying, what do I do with those exponents? I add them. So this would be 7 to the 5th, right? How about if I am dividing two numbers that have the same base with exponents? Subtract the exponents. So this becomes 11 to the 2nd, which is this one would be like 121. I'm not going to make you do 7 to the 5th, but you know how to, right? 7 times 7 times 7 times 7. It would get ugly. The number 3 is raising a power to a power. So if I raise a power to a power, what do I do with the exponents? Multiply them. So this becomes 3 to the 6th. Good. Question so far? Good? Okay, 4 is the square root of 75. So when I've got a square root that's obviously not a perfect square, I'm going to break this down, right? So I use a little factor tree. 75 is the product of what two numbers? I can do 3 and 25, and you can either spot that 25 as the perfect root there, take the 5 out, right? Or break 25 down even further. And the goal there is to get it until it's only prime numbers, that you can't go any further. And then for every two numbers, you bring one of those numbers to the outside. So because there's two 5s, one 5 goes to the outside of the radical. The 3 that doesn't have the match goes underneath. Good on that one? Yeah? Okay, and then 5, you've got a square root in the denominator. So because this is a not perfect square root, it is an irrational number, and I can't leave an irrational number in the denominator. So what's it called? Do you remember? When you get rid of it? It's called rationalizing the denominator, okay? So I want to get rid of that square root of 7 on the bottom. I multiply both the top and the bottom by the square root of 7. So square root of 7 times the square root of 7. And this becomes the square root of 140 over the square root of 7 times the square root of 7, which is what? 7. Good. Now what can you do with that 140? Do the factor tree again. Good. So 140 is 2 and 70, which is 2 and 35, which is 5 and 7. And you could have broken that down a lot of different ways. I could have done 10 and 14. And then 2 and 5 and 2 and 7. It doesn't matter. At the end, you'd end up with all the same prime numbers. So is there a number I can pull out of that root? 2. Good. So 2 2's come out of the root as 1. 5 and 7 don't have a match, so they get multiplied together underneath. And then it goes over the 7. That was the denominator. Any questions on any of those? Because you need those in order to master the stuff for today. So if there's anything that you're unclear about, you need an extra example, now's the time to speak up.
Are you going to post these notes on Notability Notes?
The written notes? So some of this vocab and stuff, hopefully you've heard of before, but some of it might be new. So the roots, obviously, we know square roots. A cube root would be 3, a 4th root 4, a 5th root 5 times, okay? So if I ask for the square root of 25, it could either be 5 or it could be negative 5, because if I square those both, I get back to the 25. 2 would be the cube root of 8. 2 and negative 2 are the 4th roots of 16, because if I break 16 down, there are 4 2's. And then when you see something like an nth root, it just means that that's the exponent, whatever that number is, could change, okay? So it could be like, a number is the 7th root of b, and that means that 7 of those numbers would get multiplied together to give you whatever b is. Okay, so you'll see the nth root a little bit. So these radicals have parts to them, okay? This is the nth root of a real number can be written as the radical expression, the nth root of a, where a is called the index. So what I want you to know from here is obviously a little bit of vocab. This index is the number that's on the outside. What's underneath is called the radicand, which, you might see again, but you won't see it as often as you'll see the word index. So index is important to know that it's the one on the outside. When a number has more than one root, the radical sign indicates only the principal or positive root. So if I ask you to give me the square root of 25, your answer is just 5. If you see it in an equation like x squared equals 25, that's when you would give plus or minus 25. Okay, but if it's just square root, you just do the positive root like this says. So then on the bottom it says numbers and types of real roots. An odd index, like there's only going to be one real root. An even, it could be two real roots, the positive and the negative. Even and a negative underneath has no real roots. Can I take the square root of negative 25? No, there's no number that I can multiply by itself to give you a negative, right? So even amount of times wouldn't work. An odd does, right? If I do negative 2 times negative 2 times negative 2, what do you get? Negative 8. So if it's odd on the outside, if that little index is odd, like a 3 and a negative 8, that you can do. But if it's even, you can't. It would be no real number. And then the last thing says the radicand of 0. So any root of 0 is going to be 0. It could be the 3rd root, it could be the 7th root, it could be the 25th root. Okay? It will always be 0. Which one, the 0 or the?
No, like the odd and the
So if it's odd, it can be positive or negative. And I can find the root. So if this was 3 and this underneath was negative 24, or 64, let's say. So if I break 64 down, I can say that this is 8 and 8. This is 2 and 4, 2 and 2, 2 and 4, 2 and 2. And you can actually bring it 2 out twice, which means it's 4, right? And I can say it's negative because negative 4 times negative 4 is positive 16 times a negative 4 is negative 64. So if this little number is odd and this is negative, I can find it. But if that's even, I can't find it. Because I need 2 of the exact same numbers to get multiplied together to give me 64, negative 64, right? And if it's negative, it means one's got to be positive, one's got to be negative. Does that make sense? So even and negative underneath, no solution. Odd and negative underneath, that you can find. All right, so this one says simplify the expression and assume that all the variables are positive. So we don't have to worry about doing positive, negative. We don't have to worry about putting absolute value on that. So start with the 81. Okay, let's break down 81. So 81 could be what and what? 9 and 9. And then 9 would get broken down into 3 and 3 and 3 and 3. So this little index now is it's not a 2, right? A square root would just be a 2. That's a 4, which means I need 4 of the same number in order for it to go to the outside. Do I have 4 of the same numbers? Yeah, I have 4 3s. So 1 3 is going to go to the outside of it. Now I've got 12 x's. So if I wrote them out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And for every 4 of them, I could bring out 1, right? So if I cross out 4, 1, 2, 3, 4, that's 1x. 1, 2, 3, 4, that's a second x. 1, 2, 3, 4, that's a third x. So what is x times x times x? X to the third. Are there any numbers or variables left over that don't have a partner? I canceled them all out, right? So there's nothing left underneath the root. The shorter way to do this is take the number on the outside and divide it into the one on the inside. So I take my exponent, which is 12, and divide it by 4, and I get 3. So there are 3 x's that can come to the outside. Okay, so take the exponent and divide it by the index. 12 was a little annoying, but if that exponent was like 37, you're not going to want to write out x 37 times and cross them out. So you just take the one that's underneath and divide it by the index or the number on the outside. Okay, now I've got quotient, which means a division problem, right? Does that 4th root go to just the top of this? It's all of it, right? So the first thing I would do is split it. And I would say that that's the 4th root of 16x to the 8 over the 4th root of 5. And then start with your numerator. So try to break that down and see what you get for your numerator. All right, so what number gets broken down 4 times in 16? 2, right? If I broke that down into the factor tree, it would have been 2 and 8, 2 and 4, 2 and 2. There are exactly 4 2s, so 1 2 goes the outside. And then if I put that 4 into the 8 for the exponent, I should have what on the outside? X squared. Okay, so that's my numerator. Now I've got the 4th root of 5. What happens if I multiply the 4th root of 5 by itself? If I just do it the way that we did the first one, and I multiply this 4th root of 5 and the 4th root of 5. Do you know what 4th root of 5 times 4th root of 5 is? 4th root of 25. Does that simplify? No, right? So when you have an index that's not 2, so if it's 2, I need 2 of them. I multiply it times itself, that's 2 of them. But if it's 4, how many do you think you need? 4. So how many more 5s do I need? I need, well, if I erase the one that I didn't have, right? So let's pretend that we never did this. From the beginning, how many would I need? I need 3 more. So I've got 1 there, right? I've got 1 there, I need 3 more. Does that make sense? Yep, so this is the 4th root of, and I could even keep it out, 5 times 5 times 5. And then in the top I have to do the same, because whatever you do at the top, you have to do, or whatever you do at the bottom, you have to do at the top. So what is the 4th root of 5 times 5 times 5 times 5? 5, that's my whole goal, right? Get rid of that root. And then what is 5 times 5 times 5? 1 less. 125. So this becomes my numerator. 2x squared times the 4th root of 125 over 5. So I'll be honest, I think these are the hardest. When you have something in the denominator that's not a root. That's a square root, okay? Just remember that you need as many of that number as you have an index. So if it was a 5th root of 3 on the bottom, and I only have 1 3, I'd have to multiply by 4 more 3s. Does that make sense? And then I don't have to go through the work on the bottom, because I know the whole goal is to cancel it back out. But on the top, I do. I have to figure out what 5 times 5 times 5 is, which is 125. And then I can't break it apart again, because it's not going to simplify. So you might as well just leave it the way that it is. Questions on that one? Okay, so the first thing you're going to do is split it, right? Well, it could be one of the first things that you do. So if I get the 4th root of x to the 8th in the top, and then the 4th root of 3 to the bottom, how do I simplify the numerator? Good, so index into exponent, 4 into 8 goes how many times? 2 times. This is x to the 2nd in the top. And then how do I get that square root out of the bottom, or the 4th root out of the bottom? Good, I need 3 more 3s. So x squared is going to go in the top, 4th root of 3 in the bottom, and then I need 3 more 3s. So I have a total of 4 3s, and the top and the bottom. So what is 3 times 3 times 3? 27. So I get x squared times the 4th root of 27, and in the bottom, the 4th root of 3 times 3 times 3 times 3 is 3. Yep.
Is it okay to put the x squared after this?
Yeah, that's fine. Just make sure that you're careful with your radical. Don't let that radical extend over the x squared. That's it. The order doesn't matter. All right, so B says the cube root of x to the 7th times the cube root of x to the 2nd. So the rule on square roots and cube roots is that as long as the index is the same, you can actually multiply. So if that was a square root and a cube root, I would have to keep them separate, but because they're both cube roots, I can combine them. And when I combine with the exponents, what do I do with those? Multiply. Or sorry, if you're multiplying, then you add. So the 7 plus the 2 becomes 9. Good. And then index into exponent, 3 goes into 9 how many times? 3 times. Okay. A little bit easier when you don't have to worry about rationalizing, right? Questions on those? All right, a rational exponent. is an exponent that can be expressed as a ratio. So a number in the top, number at the bottom. So these rational exponents are going to be exponents that are fractions. Okay? It says m and n can't be, they have to be integers, they can't be 0. Okay, you're not going to be raising anything to a 0 power. Radical expressions can be written by using rational exponents. And the denominator of a radical exponent becomes the index of the radical. So this is the most important part of this. How to get it from a fraction as an exponent to a radical. And that right there is what you do. You take the denominator of the fraction, slide it to the left, and it becomes the exponent. It becomes the index. And then whatever's in the top drops down to become the exponent. So this guy here, like this, 8 to the 2/3. Okay? The bottom slides over to become the index. And the top drops down to become the exponent. So left slides out, bottom or top drops down. Okay? So if I had x to the 5/7, what does it look like in radical form? 7th root of x to the 5th. Good. Okay, so bottom slides over, top drops down.
Is the exponent of the whole thing or just the number inside the radical?
It actually can be written either way. So that could be the cube root of 8 squared, or it could be the cube root of 8 squared, and they're the same. So if I took 8 and I broke 8 down, right, so this is 64. If I did 64 as 8 and 8, as 2 and 4, 2 and 2, 2 and 4, 2 and 2, there's 1, 2, 3 twos, that means one's going to go to the outside, and then another 1, 2, 3 twos. So this is 4 when it simplifies, right? This, and it's easier to do it that way if you can, the second way. Take the cube root of 8. So 8 is 2 and 4, 2 and 2, which means the cube root is 2, and then square it and you get 4. So if you can simplify it by finding the root first, it's way easier to do it that way, and then raise it to the exponent. But the order does not matter. They both will work. Okay? So again, bottom slides over, top drops down, and then the exponent can go on the outside or it can go on the inside. It doesn't matter. So this is just writing it in radical form. And then simplify it if you can. So first get it into radical form, and then see if you can simplify it. All right, so what does it look like when you write it as a radical? Good. 5th root of negative 32 cubed. Or the 3 could be right on that negative 32. But are you going to want to do negative 32 times negative 32 times negative 32 to then have to find the 5th root? Probably not, right? It's going to be easier to do it the other way around. So can I do the 5th root if it's negative underneath?
Yes.
Yeah, because it's an odd, right? So what's the 5th root of negative 32? Negative 2. And then what is negative 2 cubed?
8.
Good. So if it says to write it in radical form and simplify, you're going to do just that. Yep. So I would have broken that 32 down. I would have said this is 2 and 16, 2 and 8, 2 and 4, 2 and 2, and then there's exactly 1, 2, 3, 4, 5 twos. So typically it's a 2, but because of that negative, I know that those twos have to be negative in order to make the product negative. Is it the negative throwing you or the 2?
I don't know.
So if it's, let's say it was the cube root of negative 125, right? I would take that 125 and I would break it down just like I typically do. So I would do like 5 and 25 and then 5 and 5. So without that negative, this is just a positive 5. But if you have a negative underneath, you have to account for it by bringing it to the outside. Because technically that's a negative 1 times 5 times 5 times, right? And then negative 1 could get broken down. But if you just remember that if there's a negative on the inside, an odd root, take that negative right out. And then break down your number. Mm-hmm.
So let's say I'm going to let's turn it like that or 8i.
You're pretending like you don't know i's.
Okay.
Because, and technically there'd be no I with this because it's an odd root. So even root is when the i's would come into play. But you're only doing these as though they are real numbers, which would mean no i's.
If it's an even root?
You would write no solution.
Okay.
Because you're in real numbers. All the stuff that we've talked about is real numbers. So you would write, it's technically no real solution is what it is. But for right now, you just put no solution. Yep.
So the way that you did it right is that if you have all of the same number and it's the same amount of that number as the index. Okay.
Yep. All right, so same thing. Go ahead and break them down. Write it in radical form and then simplify it. Try to find the root before you raise it to the power. You can do it the other way around, but it's usually easier to do it that first way. All right, so what is the 64 to the 1/3 written as in radical form? Cube root of 64, which becomes 4. Okay, and 4 to the 5/2 becomes what? Good. So you don't need the index of 2 on there. When you've got square root, it's implied, okay? But if you write it, I'm not going to mark it wrong. And then the square root of 4 would be what? 2, and 2 to the 5th is 32. Questions on those? Those weren't so bad, right? All right, now we're going back the other way. So we're taking ones that are written in radical form and we're writing them as though they have a fractional exponent. So if the 8's on the outside, where does that 8 go in the fraction? In the bottom. So this is 13 to the 4/8. And what happens with 4/8? Gets simplified to 1/2. And what is B? Good. 13 to the 15 over 5, which becomes 13 to the 3rd. Okay, you do these. All right, so the 4th root of 81 to the power of 3 becomes what? Good. 81 to the 3/4. B, the 3rd root of 10 to the 9th power becomes 10 to the 3rd. It would be 10 to the 9 over 3, which reduces to 3. And then 4th root of 5 squared? 5 to the 1/2. So think about something that's raised to the 1/2. What does it look like in irrational form? It's actually the square root, right? So like a 1/2 is a square root. A 1/3 is a cube root. A 1/4 is a 4th root. Okay, so anytime you see something like that, it's the square root if it's 1/2. All right, so this is just a little bit of a review of all the properties that we talked about. So when you're raising, the first one is the product of powers property. If I have 2 exponents that are being multiplied together with the same base, then I add the exponents, what we did in the beginning. Okay, quotient, if it's in the top and it's in the bottom, I subtract. If I raise a power to a power, I multiply. The power of a product, so this was not in that warm-up, the power of a product, if it's written like this, okay, then I can actually distribute that 1/2 to each of those, okay? That can be written as 16 to the 1/2 times 25 to the 1/2, and that 1/2 is the square root, so that would be 4 times 5, which is 20. And then the power of a quotient, if the exponent's on the outside of a fraction that's in parentheses, that exponent goes to both, okay? So the reason that that is because these are here. So think about if those weren't fractions as your exponents and it was a little bit prettier, okay? If I just had the numbers that had the same bases with exponents and I'm multiplying, what do I typically do with those exponents? I add them. So in this case, I'm just adding, but they happen to be fractions, okay? Don't worry, they're not that bad. What is 7/9 plus 11/9? 18/9. What is 18/9 reduced to? 2nd power. And what is 7 squared? 49. So when you're multiplying, you're going to add the exponents and then keep going until you can't go any further. How about if you're dividing? So 16 to the 3/4 over 16 to the 5/4. What do I do with those? Subtract. So 16 to the 3/4 minus 5/4. What's 3/4 minus 5/4? Negative 2/4, which becomes what? Negative 1/2. What's the negative do on an exponent? Do you know this? No. A negative on an exponent takes that number and puts it to the denominator. So if I write that in radical form without the negative, if it was just 16 to the 1/2, what is that?
16 squared.
So it'd be, nope,
Sorry,
square root of 16, right? But the negative tells you take whatever's there and put it on the bottom of a fraction. So this would be 1 over 16 to the 1/2, which is 1 over the square root of 16, which is 1 over 4. So you don't have any negative exponents on your quiz or anything like that, so don't freak out too much. And there's going to be a little bit of a learning curve between you and me, like what you know already and what you don't, because obviously I wasn't here.
So when you have like the half and like when you have an exponent in the denominator, you turn it into, you put the whatever under the radical sign.
Yeah, so typically that wouldn't have been negative, that would have just been the 1/2, and then I would have just turned it into a square root of 16, which is just before. The negative is what puts it to the bottom. But again, so you actually, your first quiz is Friday of this week, and it's this section and the one we're going to do tomorrow. But there's no negatives on it. Okay? Mm-hmm.
Why don't you multiply the 7 and the 7 in the first example?
So think about what we do with any kind of base that has the same exponent. Like if it's 2 to the 4th and 2 to the 3rd, we keep the 2, but we add the exponents. Because if there's 4 2's and 3 2's, it's still 2, 2, 2, 2, 2, 2, 2. The base still stays the same, right? It's just that you need that many of them. So you always keep the base. The only time you change it is when you're actually simplifying it, not when you're combining. Mm-hmm.
For like example B, if when we get to the part where we put the number on the bottom for the numerator,
Yep.
and if that square root's not a perfect square, do we have to keep rationalizing
Yep.
it?
Yeah. So from here on out, you will rationalize. You'll never leave a square root in the bottom. Good question. Okay, last one, and then we're done. So see if you can do it on your own. All right, so 36 to the 3/8 times 36 to the 1/8 becomes what when you combine it? 36 to the 4/8, which is what? 36 to a half, which is? Square root of 36, or 6. Raise your hand if you got it right. Questions if you didn't? Yep, you want to go until you can't go any further. So the question was, how far do you have to simplify? Until you can't go any further. All right, so then B, negative 8 to the negative 1/3. So the negative does what? Goes to the bottom. So this would be 1 over negative 8 to the positive 1/3. 1/3 is what in radical form?
Radical 3, or cube root of negative 8.
Good, cube root of negative 8. And cube root of negative 8, which would be 2 and 4, right? And 2 and 2. That negative comes to the front. Would be negative 2. So this would be 1 over negative 2.
You can't move the negative to the top.
Say that again.
You can't move the negative.
You can put that negative anywhere you want. It could go on the 1, it could want to go out front, as long as you don't have it both in the top and the bottom, because that makes it back positive. Yeah. But that could be out front or with the 1. All right, and then C, 5 to the 9/4 over 5 to the 1/4. When I divide, what happens to those exponents? Subtract. So 9/4 minus 1/4 becomes? Good. 8/4, which becomes 2, and 5 squared is 25. Questions overall on any of it?